The heck happened there? Alright guys, welcome to the channel dedicated to satisfying my engineering curiosity by taking apart products that other people and companies designed and seeing how they did things. Now, if you don't want to hear the backstory and details of how I found this cheapest impact on the internet, then skip to the next section where I start the teardown. But for those of you curious as to why the box on the table has a brand name that sounds more like it should be on a bottle of salad dressing, let me fill you in. So I decided I was curious. I wanted to know what the internal design and engineering looks like of the absolute cheapest product that I could find in a particular category. And so first question was, okay, what product should that be? And I'm like, well, I've done a number of impact drivers in my video catalog. So that's probably what I've done the most of. So that would be a good reference point to start with. And then the next question was, okay, so what other criteria should I limit the impact driver to? Like, should it be 12 volt or 20 volt, for example? And so what I settled on was that it needed to be an impact driver with a 1/4 inch hex style chuck, 20 volt power that included the battery and the charger in the box. Was not refurbished or used on eBay or anything like that. Included shipping in the price to my house within 7 days. So meaning the overseas warehouses that ship to you direct from China, like Alibaba, that take 30 days by sea to get to you, you know, those were off the table. And also brick and mortar stores were off the table just to normalize for the shipping price. Although I still couldn't find a better price for this, a similar package from a brick and mortar store. So now, if you know power tools, you know that the battery included criteria is a major sticking point. Look, sometimes that can be like half the price. You know, you can oftentimes find a deal on tool only, but the battery is where the biggest chunk of money outside of the actual tool itself comes in. So, but that's what I wanted to know. If I was starting with nothing, how cheap could I get a 20 volt impact driver, and what would that quality look like? So that's how we got here with this brand name called Snap Fresh for some weird reason. I ended up finding it on Amazon. Even without a Prime account, you can get it delivered in less than a week for a grand total retail price before taxes of $39.99. And here's the receipt for your reference. Now, naturally, this product is from China. That's probably where the weird name comes from. I'm guessing it's some awkward translation of something they thought Westerners would like the sound of. But anyway, specifically, the parent company is called Ningbo Baby Tech, which no doubt refers to one of the biggest cities in China named Ningbo, where they produce a lot of the world's small electric motors. I discovered while sourcing a motor for one of my designs that there are actually a lot of Chinese companies that have Ningbo in the name simply because of this. So anyways, I hope that sets the stage for you guys now. Now I'm going to do the teardown and review from an engineering perspective and point out every juicy technical detail that I can see and fit into the next 20 minutes or so. And also at the end, I just couldn't resist. It's not really what this channel is about. I don't really test products. You know, I'll leave that to the channels that do it much better. But I couldn't resist with this particular one. It's the cheapest of a category. So I at least had to do one test to see how it performed against a baseline that I was familiar with. So if that sounds interesting to you, then stick around to the end. All right, let's get to it. So from the outside, we have a number of different materials, very similar to other brands we've had on. Semi-hard rubber, that's a little bit harder than normal, but very grippy. So really nothing to complain about on the grip front. It just happens to be harder. And it also, the overmold could just be thinner. They could be using less rubber, and that's why it seems harder, because it's a thinner, just a thinner layer. So then we got hard plastic. Could be the standard nylon 6, or maybe they cheaped out and went to polypropylene. Might be able to know once we get inside. Cheaper products tend not to put the material on there, so I might have to just make my best guess. But we got a metal can with the 4 screw configuration, which is exactly like the next cheapest impact I've had on the channel, the Hyper Tough. So there's definitely something about this configuration that's cheaper to manufacture, and when we get inside, might be able to see what that is. But we've got metal, hard plastic, soft plastic / rubber. This it's kind of got a gritty. One thing I noticed when I was using it for the test was it doesn't matter. It won't. Oh, there we go. Most of the time, it won't fall out under its own weight. So, and another thing that I noticed while using it was so you hear that like oscillating noise level. It's not a consistent noise level. That's kind of symptomatic of a cheap drivetrain. Could be a cheap motor, but most likely it's cheap gears inside of right here that make the reduction. They just don't fit as well as together as well as good quality made gears do. But and again, any criticisms I make of this is not to say that it's a bad deal for the money. I'm just going to point out where I see corners cut or not, and whichever the case may be, and then y'all can decide whether it's a good value for money. I'm just pointing out, what I can tell. So, all right, well, let's get into it further. That's about all I can tell from the outside. Okay, so definitely metal, and it's been machined a little bit, probably just to fit that bearing in there. That's a hammering. That's where the hammer impacts is on that rotor right there, and of course the weight and the mass is on this one, this right here. It's a pretty large amount of rotating inertia, and it comes in contact with that clutch dog is one way to describe it. Yeah, so there's been a coating. So there's been a coating applied on the outside that you can obviously see is not on the inside. This is most likely a zinc aluminum alloy. It's been die cast, which is a very, very cheap, cost-effective manufacturing process. Again, you can make, high quality parts with them, but even the best will tend to be brittle. Casting in general just makes brittle. The cast version of aluminum is more brittle than the forged or sheet metal, cold wrought sheet metal version of aluminum, and same thing with steel and iron and every other metal. Casting is about the lowest quality material properties that you can get, but it's the cheapest because the cycle times are so low. So you can make up for the poor properties by just adding more metal, so.
Well, I am definitely voiding the warranty.
Alright, so first, let's see. Alright, well that was really stuck on there. First, let's see what we can see on this. Well, what do you know? A cheap product that actually calls out PA6 glass filled 30. That is nylon 6 with 30% glass fill. And of course, it's not to say they're not lying, but I mean, feels right to me. That is some impressive undercutting for holding the rubber to the hard plastic skeleton underneath. That is that's among the best I've seen. They definitely didn't skimp out there. Nice big tall ribs spanning the entire gap. Nice uniform wall thickness where it sticks out farther, so they indented, which is a kind of a standard thing, design features that you want to on any injection molding. You want to religiously stick to uniform wall thickness, so the whole part, that the material flows into the part evenly, and also it cools evenly, and also you're not wasting material or making unsightly sinks from excessively thick areas. So I'm like, for the money, I'm kind of impressed. Now you might notice when I tried to bend this thing, see it really wants to bend right here, and notice a real lack of vertical ribs that I've noticed on a number of other impacts and drills, that they'll put some extra ribbing there specifically because of that right there. It's kind of the weak spot. You got all this mass up here and all this mass down here, and it's kind of, its own inertia will act on it, and right there is kind of where the rubber meets the road, and so they didn't put anything there to kind of help with that. But again, when you put the two halves together and it makes a tube, it's probably still strong enough, and probably still stiff enough. It's just they didn't really go the extra mile like they could have. So the finish on the outside of this is as good as I would expect from a high-end brand. It's a nice, D2, D3, or Mold Tech equivalent finish, and it's actually pretty pleased. I like matte personally. I like matte. Plastics look cheap when they're glossy. So yeah, I'm all right. Well, oh, and they have some rivet style undercuts that to hold on to for the rubber to hold on to the hard plastic in the middle spaces where there's no edge, in between, like the no man's land. So in case there wasn't good chemical adhesion, they have features for mechanical adhesion, kind of evenly distributed all throughout. So nothing to scoff at right there. Again, just they didn't go the extra mile with the ribbing. So all right, so what else we got? Ooh, this is yeah. Again, I'm not saying this is a bad product for the money. I'm just saying, pointing out what I see. So those are is that even soldered? Oh, sorry. Or is that just... that I think that, here, let's get this out of there. I think that has just been like pressed on there. Either way, that is not the most, robust electrical connection. I can tell by, just tell by looking at it. It doesn't have any strain relief, so the wires can bend and vibrate, right there. That's definitely going to be a weak point for the electrical system. And you notice there's frayed wire, so there, see, maybe 10 to 15% of the wires are not even connected on the positive side, and it looks like it might be brazed. I definitely see an indent on the tab, like it's been pressed together. Yeah, that's definitely solder right there. I can't really see any solder. If there is solder, it's a very small amount. So yeah, definitely that's a ooh, what the heck happened there? I don't know what that is. That's just where it's like flash from the injection molding has been cut off or ground off. I don't know. It's definitely a cheaply made part where they don't really care about quality of that plastic piece. But it looks like these contacts the plastic is over molded over these metal contacts. Plus and minus. So, all right, kind of chintzy. Not gonna lie. Then pretty standard piece here. More kind of, or at least there's a liberal amount of solder on there. Has good speed control. I'll give it that. When I was using it, it definitely has as good a speed control as I could ask for. Nice little LED to light up. That's perfect. Perfect. Have to move my bench to get that. Just wonderful. Okay, so on the screw. Yeah, so same, just a mirror image. What I was saying, when you put them together, you have a very strong shape. You have a full tube. So like now, ooh, yeah, ooh, yeah. So that versus, bending one, it's not that hard. So probably don't need ribs there, but just other companies went the extra mile and made it, put that extra safeguards in there, and they didn't. So, and there, I'm sure this is a standardized motor. You probably get from all kinds of different vendors, but there it is if you wanted to look it up. Yeah, this is probably unfilled nylon. The more glass you put in it, the more stiff and not brittle it becomes, but the less ductile it becomes, put it that way. Nylon is kind of a special material in that you add glass to it and it actually gets tougher, but the deformation at yield, so like how far you can bend it before it breaks, that does go down. So the stiffness goes up, the toughness goes up, but the deformation at failure goes down. And so you would, if you wanted a part to be super tough, that you could just hit it with a hammer and it would just bounce back, and then you put no glass in it. And that's probably what this is nylon without any glass added to it whatsoever. This is kind of the color of an unfilled natural nylon will be this color. And I can't imagine they would use polypropylene, which is very brittle, especially as it ages, that on a drivetrain that's designed for impacting. Okay, everyone, hold on. Okay, so that's probably where all that noise is coming from, is these components right here, these gears are probably, you know, made with speed and efficiency and cost in mind more than quality. So goodness, that's got to be the tiniest main gear I've seen. So those are most likely made using powder metallurgy. It's basically you use a die and then you put powdered metal into the die, and then you like put hundreds of tons of pressure, of force, you know, which creates a crap ton of pressure. That's a technical term, crap ton, to fuse the powders together, and then they put them in an oven, and then that finish is binding. They almost melt the metal, and then it chemically combines with all the molecules around it, and it's kind of a way of making fine detail more cheaply than machining. These would be, you know, fairly costly to machine, all these tiny little features, and it makes powder metallurgy makes very hard parts and very precise parts. So, but again, like everything, you can get them cheaply done or well done, and I think powder metallurgy is probably what most gears are in these types of products. But these, you know, just a little bit of like lack of roundness in this part could make every time those gears come around, then you know, and that's another technical term. It means lack of concentricity. So, and yeah, so probably I'm guessing around a 10 to 1 reduction. Builds up some steam, and then pow. There's another technical term. Pow. That's just the select. Oh, ABS. Well, what do you know? ABS is a fairly you know, on the higher end of low end plastics. So, but oh, this is a perfect example. So you see those sinks right there? You see how it's concave? You see that? That is from having too much material. So you see they kind of corded out, but everywhere that a rib crosses another rib, it's a little bit thicker right in the middle. And also those ribs aren't like there's extra material, you know, on the outside here, and it's like really they probably just sort of cord that whole thing out. It doesn't need the ribs in there. But anyway, that's what happens. It makes sinks. That's exactly one of the imperfections that happens when you don't use uniform wall thickness in an injection molded part. So, and especially on an unfilled amorphous plastic like ABS, it'll sink a lot. All right, guys, here's the test I was referring to earlier on. Just making sure both screws are the same height out of the wood to the thousandths. Really simple test, but also a very revealing test. So let's see how it goes. Yeah, my go-to rigid, 15 years strong. 3.46 seconds. All right. Probably not going to be a tough time to beat for a 15-year-old 12 volt. And it's not. So 2.03 seconds, which is 41% faster. So overall, not bad for the money. Anyway, if you like this kind of content, give me a like. If you really liked it, give me a subscribe. And if you really super duper liked it, then you know, share it with a friend that might be interested in this type of content as well. So hope you guys enjoyed it. Any questions, anything I didn't cover, anything you want to yell at me for, you know, it was stupid, you didn't talk about this, what you said was wrong, plop those all down below, and I will try to address every single one. So, all right, until next time, guys, see you later.